I got a call from a property owner right here in Point Pleasant, New Jersey that had got a letter from JCP&L concerning their electrical meter enclosure. That's the meter, the round part. The enclosure is what the meter sits in. He got a letter from JCP&L to replace this meter. And once I take off this cover, you're going to see why. What you see here is the inside of that meter enclosure. And at the top is what we refer to as the line side. This is the power that's coming from the utility down the conduit into the top of the meter, known as the line side. The current goes through the meter so it can be measured, and then it leaves on the load side, which are the lugs at the bottom. From the load side, they go into the main breaker or the main disconnect. In any event, the damage incurred because this conductor was improperly terminated. After putting together a proposal, and once it was approved, I secure a deposit, and then I'm able to apply for the permit. And the state of New Jersey has 20 business days to approve or disapprove a permit application. So legally, I'm not supposed to do this work until I obtain the permit. Of course, if it's an emergency, which it wasn't, then there's exceptions for getting this done sooner. So once the permit's approved and paid for, I'm able to go do this work, and that's exactly what we did today. So there was a lot of rain in the forecast during this week, and it was a 90% chance of rain on this day, but I didn't see any of the rain falling in the hourly predictions, so I went for it. Of course, can't really do this work while it's raining. Obviously, electricity and water, that's the first major concern. The other main concern is my tools. You know, they cost a lot of money to have these specialty tools that I use and you see me using in these videos. And so the last thing I want to do is keep them out in the rain because they'll rust. And how do I know that? Because I've had it happen to me. So obviously here I'm just disconnecting from the utility, and this actual connection point right here is known as the service point. This is where the responsibility of the utility ends and where the responsibility of the homeowner and the private electrician begins. This is known as the service point. Anyhow, so I'm just cutting out the service drop area, so when I cut back in, I can use the smaller butt splices that I use. And I'm pretty sure JCP&L comes back here and redoes these connections, but I saw no need to cut out from the existing 200 amp side, so I just cut the drop and reattached it later on after all the work was done. And even though I disconnect this power right here, always important to me when I go back down to check the meter and make sure that it's dead, which of course I do here. It's really important to disconnect the lugs from the conductors here because I'm going to be reusing the conductors. And so I don't want them to be any smaller than need to be. I don't need to cut them out because then they won't fit back into the new meter. The biggest challenge of this job is to get those conductors back into this meter without having to replace any of them. You'll find out if I have to do that coming up shortly. At this point, I don't know what the future holds of this job. If I'm going to have to replace these service entrance conductors or not. I'm just trying to get this meter out, and then we'll figure that all out. Sometimes the most difficult part of the job is getting the old stuff out before putting the new stuff in, especially when you're trying to retrofit an existing installation like this. You see the J channel going around the meter there, the enclosure. Well, the new enclosure is about 5 inches taller than this one. So how are you going to make that work? You just get in there and you use your 35 years of experience to do that. So part of getting that out is what I'm doing here is I'm reversing the lock nut. It's a 2-inch lock nut between the back of the meter and the inside of the panel. And so sometimes there's rust and who knows, God knows what could be back there. But this took a little while. Eventually just undid the lock nut. Well, first I got to undo the bushing here. I'm doing the plastic bushing first. And I'm going to reuse that if I can. I'm going to keep it on the truck in case I break it or if it snaps. It is a plastic bushing. All I'm doing now is just trying to get this connector loose. And so this comes in two different pieces. This is the top half of the piece, and the other piece screws into the hub on the top of the meter, and then we put duct seal on the top of that. Yes, I've read comments, my own videos, other electrician videos. You can't do this in Texas, and you can't do this in California, and you definitely can't do this in Oregon or Washington. And so what I usually tell people in the comments is, I say, next time I do a service in either one of those states, I'll remember not to bring the service entrance cable or my giant channel locks here. But this is how we do it here in the Northeast. I believe all the way from like Washington, D.C., all the way up to Maine, we have service entrance cable conductors, risers, masts, so to speak. I shouldn't say mast, but the riser portion of the service goes between the meter and the weatherhead. And so everything that we do as electricians, we have names for, so we can talk the same language. It's pretty important to know your definitions. I'm not trying to sound like an instructor right now, but it is important. If you know what something's called, then you have a point of reference if you want to talk to another electrician about it or discuss it, especially online or Facebook or Instagram or YouTube even. So here's a strap. This is a service entrance cable strap. I don't particularly like this kind. There's a set screw that goes behind the cable here, and that screws to the sheathing, and then you fold those tabs over. But all I'm trying to do here, it's not the greatest camera angle, is just pull that service entrance cable out from the meter through the connector, and then I'll be able to remove the meter. This thing's not even that old, and whoever did this used flathead screws. I want to say this is maybe 1990s, maybe 1980s at the most. But obviously, you can see there's damage that's been done there. When I undid that lug, the whole assembly just kind of came undone. So it had been frying for years. I found out later on that the renter here told me that sometimes half the house didn't work. And I didn't get too into it, but I have a funny suspicion that this loose lug on a certain day might have just disconnected and not let the full 240 volts through the meter and into the main breaker panel. And by changing this meter, I think that's going to change as far as the power that didn't work in half of the house. So when you hear half of the house, most of the circuits in our house are 120 volts, right? So on each side of the panel, one leg is 120 volts and the other leg is 120 volts. And what we wind up doing is supplying our branch circuits from 120 volt circuits from the supply, I should say. And so if one of those is out, well, then nothing's going to work. The circuit breakers that are connected to that side is failing, if that makes sense. So obviously, so I got the old meter out, and so now you can see that this meter is a lot larger. So I'm going to wind up taking out that top side of the J channel and remove it so I have room to attach my new meter. Of course, it's going to take a little while to attach the meter because I still got to get that service entrance cable through the new opening, and of course I got to line up the nipple at the load side of the meter. So there's really a lot going on here. It's really a small job, but there's a lot of little details like that. And so if you've never done this work or you're just starting out and you want to try to do this yourself, you should just know that there's a lot to do here. It's not something simple. I like to think I make it look simple, but it's not. So there's my Milwaukee multi-tool, or the oscillating tool. and I'm going to cut that J channel off. I got so many bits. They're always on sale. I can never help myself when I'm at Home Depot. Obviously, you can tell by my truck. Right? I have everything. I always wanted everything when I was younger, working in the trades, and now I'm at the age where I can have whatever I want. And it's a great feeling. So I love buying tools, and I still love doing this work, and I hope you learn something from this video that you take for the rest of your life, or the rest of your career if you're a young electrician. Now, for me, these are 9-inch diagonal cutters, dikes, so to speak. I have always used the 7-inch ones, and I decided to buy these 9-inch side cutters just to give them a shot. And so here they serve the real purpose. This is how I remove that concentric knockout by opening up the 4 sides and then splitting it with the diagonal cutters. I used to do this with the 7-inch, but I get a little more leverage with the 9-inch. Which is also why I switched back to the 9-inch lineman pliers, the hybrid style. I think when the hybrid Klein lineman pliers came out, I think they were only 7-inch, and then I found out they had the 9-inch, and I said, let me get those 9-inch. I'm so used to working with 9-inch pliers. I got a whole garage drawer full of old lineman pliers that I just never threw away, but you can see the battle scars they've gone through, if you know what I mean. If you're an electrician, I know you know what I mean. So this is these tools today, the best they've ever been. Obviously, they just get better and better. I've stuck with Klein all the way. I've tried using the Milwaukee. I've used the Ideal. I never bought the Weha or whatever that other Knipex, whatever. I like the Klein name. The Klein got me this far. I'm gonna stick with them. Now, while I'm putting this lock nut on, the nipple's only coming through maybe 2 or 3 threads, just enough to get this lock nut started on the nipple. And then once I get it started, I know from experience that once I keep making that lock nut tighter, it's going to show more and more threads. And I really just need to see enough threads to get my plastic bushing on. And the purpose of the plastic bushing is so you don't damage the insulation on those conductors as you're pushing them through. But as you can see here, they're already there. I do wind up changing these, but you'll see that in the coming moments here. But right now, I'm still just trying to get that lock nut on, just enough so I can get the bushing on and move forward with the work. And the nipple keeps popping out, like back, it keeps moving back. I only have the one screw in now for the holding the meter enclosure to the house. And the lock nut started, but there's no more threads and it's hard. I'm just trying to get a little more space so I could push the meter enclosure back and have an easier time locking down or making tight this lock nut. And so here I think I do that, and I'm just going to bang away for a little while. Yeah, much easier now. See that? So now I go around a couple times and I'm able to get the plastic bushing on and move on. And by the way, if you didn't already know this, aluminum is a lot larger than copper. So every size aluminum is going to be larger than the copper size. This is 4/0 aluminum versus 2/0 copper for the same 200 amps at a service. You could speed this up. I could speed this up by using some tape, just taping those conductors tight together. Because they've been, a distance apart like that since they were installed 30 years ago, they're not just going to go back into form the way they were before. So I could slip this part of the service entrance cable connector. You got to be able to fit these conductors through. So if you're looking for a quicker way to do this, you could tape those conductors together and then be able to push this on there a little bit easier. Looking back on it, that's probably what I should have done here. But I'm just, how do I get it done as quickly as possible? So I'm going to use my channel locks here just to tighten these up, just to get this lock nut up in there. And then once I do, the rest of them go pretty easy after that. I need the pieces of this connector to stay up and away so that I can put the service entrance cable into the meter enclosure. So I just use my vinyl electric tape here, or my vinyl tape. You call it vinyl electric, or you call it electrical tape, but it's just really just vinyl tape. It's expensive. This is Scott's 33. I probably should have used the cheaper stuff to do this, but it's in my pocket, and I like to use good tape when I can for all my electrical connections. But here, I didn't need to use that. But that's what I'm doing there. And eventually I get these up, and then I'll get them inside, and then I'll tighten down the connector with 2 pairs of channel locks. And then you'll see in a moment here also where I do the duct seal to keep all the weather out. That's how we do it here in the Northeast. And I think I said it earlier in this video, but I know you can't do it like this in Texas. And you can't use service entrance cable in California or Oregon or Washington. And if you're watching from one of those states, are you impressed that I know how to properly pronounce Oregon? See, that's one of the things you learn when you're in the Navy. There's always somebody from Oregon, always somebody from Texas, California, etc. But I used to say Oregon, but ever since my days in the Navy, I know that it's Oregon. So congratulations. I know you can't use this service entrance cable up there, but from Washington, D.C., all the way up to Maine. This is how we do the services with service entrance cables here in the Northeast. I have to use my oscillating tool here to cut the service entrance conductors because the ratchet cutters just simply won't fit around that tight space around the conductor to cut it. There's not enough room. So that's why I use the oscillating tool. And with aluminum, it's very easy. With copper, it would be a little bit longer, a little more endurance to destroy copper compared to aluminum. But yes, I'm replacing the service entrance conductors here, and so I'm working, and I got to wrap it up and go get the leftover copper that I have in my house and come back and install it here. But I want to remove it all before leaving, and so that's what I'm doing. So we're replacing both the two ungrounded conductors and, of course, our grounded neutral from the service. If you like this video, do me a favor. I don't think I've asked one time, but like this video because it helps out in the algorithm, as you know. Thank you. Little pro tip here. So what I used was the rubber splicing tape to keep all those conductors together uniform so I can get them underneath this lug. This is a pretty important connection here at this panel. This is my grounded leg from the electrical service, and so this provides the grounding system for the house, the initial pathway should the outside service drop be affected by transient voltage and lightning. This grounded path is going to come down this grounded conductor, where of course where it gets bonded to our grounding electrical conductors. And so this is a pretty important termination here. So make sure you take your time and get a nice connection. I do not like these old GE panels. I'll tell you what, this terminal, this grounded terminal is like right next to the main lugs. I guess square D's kind of like that too. I don't know. I don't like this particular style of lug to attach such an important conductor. I mean, not that they're not all important, but this one especially carries the ground from the service to the enclosure here and provides your solidly grounded system, so to speak. Okay, this is your grounded neutral. This terminal, whatever, it was like that for how many years, but then again, I'm here making a repair, so is it really a good installation? Let me know in the comments what you think. The idea here is to get this tight bend on the conductor before I push it through the nipple. That's because the main breaker, as you can see, is like right below where that nipple is. So there's not much room to work. And so if you get this termination first, it's a lot easier to work on the other side, but there's not a lot of room in the meter either. So it's usually 6 half dozen the other. But as you can see here with this prefab bend that I make, the conductor's a little bit long. I end up trimming it back, but you can see that it's not a lot of room there. So I make that bend and I come back, I'll tighten this up, but I'm going to take this back out because there's too much copper showing. Here's where I decided, you know what, I could do better than that. Don't leave all that exposed conductor if you don't have to. So I trim it back and get it back in. I probably could have trimmed off another ½ inch or maybe a ¼ inch. But I thought I was doing the right thing here and I left it. You'll see, looks nice. Take the time, wire it up like it was your own house, and you'll be just fine. This tool I'm using to tighten down this lug is known as a T-handle hex head driver. It comes in a set, and it's probably somewhere between $60 and $100 for the set. That's exterior rated duct seal, and we form it around this connector to keep the water out. It's just an extra layer of protection. This is how we do it here in the Northeast. And if you haven't heard already, you cannot do this in Texas. You cannot do this in California. You can't do this in Oregon. You can't do this in Washington State. And I imagine you can't do it in New Mexico and Arizona also. But if you're from those states and you want to chime in, leave a message in the comments. I'm just doubling down. This is how we do it. And most electricians will tell you that this is the acceptable way, and this is the way we pass the inspection. This is known as the fifth jaw. So this didn't come with the meter, it's an auxiliary part, but I know from experience that they're looking for this now in their new meters. So what this is just a way to measure the neutral current. From what I understand though, the meter, especially the meter I'm putting back in here, has no reason does not have a fifth jaw. This is what we call the fifth jaw, and this just snaps into this enclosure made by Millbank. Took a little while to get it in there, and it goes in there, and basically what you do is you run a little jumper neutral wire from the lug on this fifth jaw on the other side of my hand there, you can't really see it, to the grounded leg. And basically it's just a jumper so the meter, if it has a fifth jaw, can monitor the neutral current. PSE&G's been using the fifth jaw forever. PSE&G's in North Jersey, in Long Island. JCP&L is also in North Jersey, but they're also mostly prominent down here in Ocean County. And so I figured I'd put this in before they told me I had to put it in later. So that's what I do. You buy this separate and just tap it in here. You'll see in a moment.
And that's it. You take your
I know I've been over this detail before, but this is so important to plug this nipple between the outside and the inside. Even though it is in the garage, it's probably not going to be a conditioned space. We still need to do this to prevent any condensation from forming and forming rust on the inside. And of course, if you get condensation, it's going to be right on top of those service entrance conductors, and you saw how they got terminated at the top of the panel and go into the top main breaker. You could definitely see water just go right inside those lugs inside the main breaker panel. So very important to plug up that connector between the outside and the inside with duct seal rated for exterior use. If you're wondering, is that live? Yes, that's live right there. It's a 120 volt leg from a 120, 240 volt single phase transformer, pole mounted transformer out on the street. All right, so there's potential for electricity to flow between that conductor and ground, and that conductor and the other conductor making 240 volts. So yes, you got to be careful here. Never put the meter in until you're done making the splice. If your utility allows you to make this connection yourself, not all of them do. Here in New Jersey, it specifically states that if you have a licensed electrician and you have a permit to do that work, even if you didn't have a permit, if this was an emergency job, you have 72 hours in New Jersey to submit a permit for this work. So in the event of an emergency, you can do this as a licensed electrician. It's one of the benefits of having your license in your own business, to be able to do this. I just don't think there's enough utility workers to keep up with the demand to come out and turn things off at, when an electrician makes an upgrade like this. Of course, you can schedule to have that done, and the other electrical contractors in New Jersey will tell you that it could be a nightmare getting JCP&L or PSE&G, who I think is a little bit better, to do anything. Especially these meters, if they're underground, we definitely need to have a shutdown. You saw me do that about a year ago in Tom's River in that video where it was underground service and I was working live. It's very dangerous to do that. I really took a chance that day. I felt confident, and guys still do it. They might not put it on YouTube like I do, but the utility company frowns upon doing that, and it's very dangerous. Never mind that they frown upon it. It's very dangerous because that arc flash could kill you in a heartbeat. It's really that simple. So here I'm just using these butt splices, and I go around with rubber tape, and then I come back with the Scotch 33 vinyl tape, and that's my connection. So right now, down at the meter, I have 120 volts to ground. And then once I connect this other leg, I'll have 240 volts between both of my hot conductors and 120 volts between each hot conductor and ground. From the street, this is aluminum. We're about maybe 2 or 3 miles away from the beach here. This is Point Pleasant Borough, but we're right near the Point Pleasant Canal at this house. So that's all salt water. So there's salt water in the air, but not so bad here apparently. So this is an aluminum drop, and this is probably number 2 aluminum. It's in free air, so the ampacity ratings are a lot different than they are in your house. For instance, the 200 amp service that's run up the side of the house here up to the service point is 4-aught aluminum. Yet we attach it here to number 2 aluminum, and that's okay. The reason why that's okay is A, the utility says it's okay. They have their set of engineers, and because it's in free air, so the heat that builds up inside of a conduit, electrical conduit, in a normal situation inside your house or in a factory or a commercial setting, the ampacity rating is going to be a lot different than if it was in free air. So we routinely connect the number 2 aluminum here to a 4-aught conductor without problems. But what I did is I was just cutting the service drop, and I reattached the 2 pieces of the service drop back together, because that's what I had to use to make this connection. And that reminds me, I gotta pick up some more 2-inch rubber splicing tape because I'm just about out. Hey, if you like this video, do me a favor, hit the like button. And if you haven't already subscribed, please do that. I appreciate you all the way. Thank you. Here you can see there's a little bit of damage to the meter because of that meter enclosure, which is why we're there. So I don't know if JCP&L is going to come back out after this repair was done and replace that or what, but I had a hard time getting it into the newer meter enclosure. So I used some of this Penetrox that's required by the utility company for terminating the conductors, but very rarely do I have to put it on the meter jaws here. But by doing that, it acts as a lubricant to get into place. And of course, it's not a conductor, So it's completely safe to do this, but as you can see, there's some damage to that meter. So they're probably going to come back and replace that with the 5th jaw. Now, obviously, the best way to do this is to put the load side in first, and then the line side. And right here, I just use pressure. Be very careful; you don't want to slip, obviously, and fall in and touch one of those lugs. That would not be good. But here we go; it's in, and then eventually, I'm going to put the meter cover on, and we'll be good to go. But of course, we always have to mark. We don't always have to do this. This is just something other electricians do. But we like to mark the inside of the meter cover here. Let them know the date. I usually put my license number on there, and then of course the temperature. And today it was hazy, and I think it was 69 degrees. So 5:30:25. My license number is 16557. I got my electrical license in 2009, and here I'm going to put hazy, but I don't know exactly what the temperature is, so I look it up real quick, and it's 69 degrees. So it was very humid today. Like I said, I think it was like a 90% chance of rain today, but the hour-to-hour prediction, as you can see there, it updates in a second. The hour-to-hour prediction was no rainfall, so I went ahead and did this work. The worst thing that you could do is start it and then have it start raining, but I had a feeling it wasn't going to rain. I got done. It had a couple drops about almost at the end of this video, which I had to stop for a minute. And then we're all set. Put this cover on. Hi, this is Ron from Classic Electric. YouTube thinks that you'll like these 2 videos on the screen, so go ahead and check them out. Don't forget to leave a comment, like and subscribe, and we'll see you on the next video. Thanks for watching.